Alright, we have done this circuit. We will now try to make it so that we can control our pins and basically try and make the LED go on and off by code, by using programming, which is not as hard as it seems. I will guide you through this process. First of all, what we need to do is we will need to rewire this little LED that we want to use. What we need to do, what we used to do, is we went from the plus through resistor, through the LED, all the way back to the minus. What we will now want to do is, instead of coming from the plus, we will use what we call a GPIO. Because we want to control when, again, this is an output, when we will want to send energy. And if we want to choose when to send it, we use a different pin. We use a pin. This word will come very often. It will note to a GPIO, which is a general purpose input and output pin, which are pins on our Raspberry Pico that we can control. Each one of the other pins, I will go back to the schematic for a second. Each one of these pins will have a little function. So here on the top, we've got the ground, which we have used up until now, and a 3 volts tree. So these two we already know. This ground, GND, we also have one here, 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 and here. So there's a lot of them because we always need to close our circuits, and to close our circuits we need to go back to a ground. We have solved the need for more ground ports by using this rail over here. Keep that in mind. So we've got the 3 volts tree, which is our output. It's noted even, out. And that is about our only power pin that we have, but it's strong enough to mostly provide us from power where we need it, so don't worry about that. All of the rest, starting with GP, is a GPIO pin. Is a pin we can use to program. Note first the GP pins. Don't sweat too much about other pins that are on here, like everything from the side. Don't worry about it. First of all, we're gonna see the GP pins, what they can do. And we will mostly work with this GP15. Why? Because it's very easy to find. It's just here at the bottom. So the first thing we will do is I will re-add my little LED. So again, I put the long leg closest to, so that I know where it is. And then I put my resistor in front. Next step, once I've done that, I have now not put it straight into the 5 volt pins because I will need to program this little pin. Now I can put my ground. The light will obviously not turn on. I don't have a closed circuit. What I can do, however, to check if everything is okay, if my LED is not broken, for example, I can just very quickly add this wire, plug it into the 5 volt. If it turns on, I know, okay, my LED is working, I am fine, I don't need to worry about this. It's all about trying to make sure that everything works, try to get rid of all uncertainties. And if you start out and you put your LED, then that is an uncertainty that it might work. Now I know if I plug something in next to the resistor, that the light will turn on. Right? So this means, okay, this part of the circuit is fine. I can forget about it and I can use this wire now. I can straight plug it into this GP15. This is the genius of a breadboard. Otherwise I should have soldered it to the Raspberry Pico, but right now the power is coming through the GP15 pin, through the orange wire, through the little resistor, through the LED, back through the black wire to the ground pin. And this ground pin, again, we did this in the first class, is connected to ground. So that means this is now ready to go. This is now a circuit and I can start programming it. Meet Tony. Tony is an interface that we will use to program our little Raspberry Pico. It's not the prettiest one, but it is very functional for what we need it for. Know that this is written in Python, MicroPython to be specific. That is a little Python style language that we can use. It's actually Python, it just have some improvements that we can use to program this little Raspberry Pico. First of all, what you will need to do is set up your Raspberry Pico. And to do that, I think I can simulate it by holding down the boot select pin. that will cause it to start up in a different mode. Here at the bottom, you can just see it, there is this little menu. And if you click on it, you will have the option to say, okay, I want to install MicroPython. You click on it, you select the volume, in this case our Raspberry Pico, you select which one you want to, the MicroPython family is RP2, right? So target volume is your Raspberry Pico, which should already have a name. I cannot put that in there, okay, the MicroPython family is RP2, the variant, wow, is Raspberry Pico W. Is it the Raspberry Pico 2? Yeah, it's noted Raspberry Pico 2W. And that one we can install. If you hit install, it will start installing it onto the Raspberry Pico. I'll just screenshot and put that on Canvas, how to set it up. It will install the firmware we need to work with it, and then it will reboot. Once it has rebooted, then normally we should be able to re-find the Raspberry Pico here at the bottom. And if you select it, and you can just plug it out and in, and now I should be able to say, okay, I am running the Raspberry Pico. It doesn't matter which one you actually select. So that's the first thing. I think we will do this in the next class just to be sure that everybody can connect to the Raspberry Pico. So now what we have done, and I can put this in a little comments. Comments are with a little dash. I have put the LED on pin 15, and that is GPIO pin, but that's not very important. If you put a little hashtag in front of your line, that means it's a comment to yourself, and it's always good to leave little notes to yourself, and just to be sure that you can always refer back to what's happening. I can put this here. So I have done that. Let's clean the background a little bit just to be sure. We can note that it is indeed in the pin 15 based on the schematics. Now I need to do two things. The first thing, and that's actually what we always need to do. The first thing we always do, we import machine from, machine, we import pin with a capital. You don't need to put these little marks, it's unnecessary here. This is Python, it is very sensitive to indents, but not sensitive to anything else. So that's one thing. If I want to be sure that everything works, I can already run it. What is happening when I hit the running symbol, okay, I need to put it here, is it sends the code that I've put here to the Raspberry Pico, and the Raspberry Pico will run it. When I put little statements, for example, print, okay, I need to stop clicking that interface, print, and then hello world, for example, in my code, and I run it, Control R or run here at the top, that means that it will send the code towards the Raspberry Pico, and it will come back, and you can see here that it has indeed printed it out back to my computer. This is basically your console log of this language. Everything you put in print, he will send back toward the little Raspberry Pico will send it back to your computer. So that's very interesting to know. Now we wanted to turn on the LED. So I can leave this one here and just say, okay, alive, so that I know it is indeed alive. And then I want to say, okay, I need an LED, and let's see, I need this LED. I don't actually need to put this in capital, I'll put it in small caps. This LED is from a certain pin. I want to speak to a pin. What kind of pin? I want to speak to pin 15, and it is an output. A lot is happening, I know, we will go through this code later on. What I can do now is I want to say, okay, toggle that LED for me. And now I can run it. If I run it, you will see that my light just turns on and off if I click run. What's happening? First of all, the first line, line 3, is basically saying, okay, I want to import the library called machine, but I specifically want a part called pin. Why pin? Because that specific item in a library, if you don't know what libraries are collections of code that somebody else, somebody smarter, has written for us so that we can easily work with these systems. I will just put my own webcam on here for a second because I think that is somewhat easier to follow. Okay, like that. Cool. So what is happening? First line is this import, right? It takes this machine library, which is a bunch of code which has a lot of different parts and pieces that we might use to make our code easier to write. And we say, okay, I want to import the specific part that is called pin. I want to work with my pins. I want to send power through my pins. So first of all, give me this little tiny piece of the library. Why do we only import a small piece and not just the entire library? Because in this way, it's easier to use throughout your code. You can just say, okay, pin here, pin here. I'm just using this reference to the library. If I don't put it, if I just say, okay, import the entire machine library, I need to start everything with machine.pin, which is harder. And secondly, I am also importing extra code onto my Raspberry Pico, which can cause it to run slower. So next line is this print. We've seen this. It basically sends this back to the terminal. Line 7, I make a new variable, and you can do this literally and just, I don't think you can actually in Python. Can you add a var? No, it doesn't recall it. You just, if you need a new variable, you just start writing a name, give it a name. Mind you, this is not very clear if you make the same variable twice. If I do this and I say, okay, I'll do something else on pin 14 and it is an input, then my program will think that this is the same variable. So I can no longer use let.toggle, for example, on it if it is an input pin. So keep that in mind. Always be wary about how you call your how you're calling your variables. I will start putting these dot commas on every line just to be clean. So what I've done here is say, okay, I make a new variable, and what I want in this variable is I want it to contain this reference to a pin. What kind of pin? It's an output pin that is noted here, right? So out is an output pin. I want to send power to it, and in is it's an input pin. I want to read what's coming in. And 15 is the number of pin that I am using. But then once I have defined this, I can use this let throughout my entire code to just do whatever with it. But the first thing I do with is I toggle it. I basically say, okay, I want you to turn on or turn off this LED. If the LED was already turned on, turn it off, otherwise turn it back on. And that is an easy way of toggling it. If I want to be sure what's going on, if I really want to say, okay, don't just toggle it, I want to be absolutely certain what's going on, then what I can say is let.value 1, and that will turn it off. If I turn it to 0 and I run, that will turn it off. So on is 1, is binary, and off is 0. So now I can specifically control what I want to do with it.